Black hole is one of the most fascinating term and also most mysterious object in our universe. Don't let the name fool you. A black hole is anything but empty space. They're extremely dense, with such strong gravitational attraction that not even light can escape their grasp. The Milky Way could contain over 100 million black holes. At the heart of the Milky Way lies a supermassive black hole, Sagittarius A. The colossal structure is about 4 million times the mass of the Sun and lies approximately 26,000 light-years away from Earth, according to a statement from NASA. Black holes is a great amount of matter packed into a very small area. Think of a star 10 times more massive than the Sun squeezed into a sphere approximately the diameter of New York City. The result is a gravitational field so strong that nothing, not even light, can escape. There are 4 types of black holes: stellar, intermediate, supermassive, and miniature. The idea of an object in space so massive and dense that light could not escape it has been around for centuries. Most famously, black holes were predicted by Einstein's theory of general relativity, which showed that when a massive star dies, it leaves behind a small, dense remnant core. If the core's mass is more than about 3 times the mass of the Sun, the equations showed, the force of gravity overwhelms all other forces and produces a black hole. Scientists can't directly observe black holes with telescopes that detect X-rays, light, or other forms of electromagnetic radiation. Most black holes form from the remnants of a large star that dies in a supernova explosion. The most commonly known way a black hole forms is by stellar death. As stars reach the ends of their lives, most will inflate, lose mass, and then cool to form white dwarfs. But the largest of these fiery bodies, those at least 10 to 20 times as massive as our own Sun, are destined to become either super-dense neutron stars or so-called stellar mass black holes. In their final stages, enormous stars go out with a bang in massive explosions known as supernovae. Such a burst flings star matter out into space but leaves behind the stellar core. While the star was alive, nuclear fusion created a constant outward push that balanced the inward pull of gravity from the star's own mass. In the stellar remnants of a supernova, however, there are no longer forces to oppose that gravity, so the star core begins to collapse in on itself. If its mass collapses into an infinitely small point, a black hole is born. Packing all of that bulk, many times the mass of our own Sun, into such a tiny point gives black holes their powerful gravitational pull. Black holes have 3 layers: the outer and inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, where the object's mass lies, is known as its singularity, the single point in spacetime where the mass of the black hole is concentrated. No matter their starting size, black holes can grow throughout their lives, slurping gas and dust from any objects that creep too close. Anything that passes the event horizon, the point at which escape becomes impossible.